Yes, Chele, unmute and then start the word of prayer. Go on, Chele. You can lead us. Start the prayer. Uh, Thank you so much, Chele Secondary School, for the word of prayer. I know some of you are not hearing well, but thank you so much for that word of prayer. Now, today we want to welcome you for this mathematics session. We are going to have a discussion about the mathematics. Unfortunately, our facilitator is not yet online, but is getting here. But as the facilitator gets online, that is going to be taking us through, we are going to be discussing a few things as we wait for him to get online. But I want to thank all the teachers that have been able to connect the children. Now, what are we going to have today? So today, our discussion is going to be rotating one. Let me share my screen. Yes, Ali, I know now everyone, you have a hint on what you call the elements of construct. Like when we are setting now mathematics, we set it in form of the elements of construct. And this is where we want to This is where we are going to concentrate such that we can plan much better for our mock examinations. If we do not plan better, it means that we are going to find challenges when it comes to doing these papers. At this level or at this point, we don't expect any of you to spot. We don't expect you to spot that this is the area that I'm going to read. This is the area that I'm going to be specializing in. We expect that at this point, you read each and everything that your teachers have been able to give you. But I understand that we have not been able to master everything, and therefore we are not yet competent in all the sections. Therefore, this session, we are going to be concentrating on some of those sections such that we can be in position to do much better. Therefore, what are we going to do? Now in math, we have these four important sections that we need to pay attention to when we are revising. And these sections are going to be the numbers, patterns and algebra, data and probability, and then what you call geometry and measures. So those are the four major important sections that we need to know. But in those four major sections, we have topics that you must have at the fingertips, because those topics at your fingertips, those topics that we are going to be discussing, those are the topics that you must know as a child, as a student, preparing for your mock examinations, but also preparing for your papers. So when it comes to numbers, we expect you that now by this time, you know what you call the number bases. You can work out what you call the number bases, anything. Under the number bases, here we expect you that you can be in position to convert from one base to another. This is converting from one base to another. We expect you that still under numbers, you can be able to do what we call working with integers. And under here, we expect you that under working with integers, here you must be sure, or you must be very competent in one, writing in words. For scenario questions, since they are in words, here, one of the things that is going to be very common is when it comes to writing money in words. You're going to find that they'll be giving you money in words or other things in words. So working with integers, we are going to be checking, do you know how to write this money in words? When they say 3,750,000, can you be able to write it from the words to numbers? So that is what we call working with integers, but it has other sections. Then still in the same, you need to know what you call the rectangular Cartesian coordinates. Under the rectangular Cartesian coordinates in the 2Ds, you must know, do you know how to plot figures? So here we are testing for your plotting skills. Can you be able to draw your Cartesian plane and label the different axes? That is under that same number. But still in the same number, we can be asked to deal with what we call numerical concepts 1 and 2, where you covered things like indices, where you covered things like SADs. If they give you some numbers, they may ask you that leave your number in SADs. If you have SADs, can you be in position to deal with those things? And then this topic, even let me write it in another color to show you how important the topic is. And that topic is going to be what you call ratios and proportions. Now, when it comes to ratios and proportions, this is one of the topics that can cut across all the 4 other sections. You can find it in patterns and algebra. You can find the same concepts in data and probability. You can find the same concept under geometry and measures. So it is really very important for you to understand the ratios and then the proportions. So under ratios, here we expect you, under ratios and proportions, we expect you even to know what we call the scales, map scales, because here they can give you even the map. We can give you a map of any country or a map of your area or any area. And then we ask you to estimate the area of that map. You have seen a case in point. They can, when you are buying land, in most cases, when people are buying land, they give them the framework. They give them we call it the land title. We can as well give you that land title, and we ask you to estimate the area of that particular land when we have been able to give you the distance. So meaning that now under number 1, there is a lot that you need to know. And here, when we are combining, it can be combined into one number, whereby that number can have an idea about ratios and proportions. It can have things with working with integers, and it can have something like in indices, meaning that you must be very sure and you must be very competent in all the areas such that you can be able to pass that number. And do not forget that this is going to be your number 1, item number 1. So meaning that if you are to pass highly, or to score the maximum of 20 per number, it means that you must be very sure, or you must be able to know all these topics such that you are very sure that this topic I'm going to be very competent. Number 2 is what you call patterns and algebra. Under patterns and algebra, we have 13 topics in it. And in those 13 topics under it, we have topics that are common, that are easy for us to set what you call the word problem, or what you can call the case study problems. And now under those topics is where you're going to find sequence and patterns. You're going to find things concerning equations and lines. So allow me to write those topics that are very common, that where you can easily find a real life application, but also can be asked very easily when you are using words. One of them is what we call the equations of lines. When we talk about equations of lines, do you know how to use y is equal to mx plus c? If you know how to use it, do you know how to obtain the gradient that may be y2 minus y1 out of x2 minus x1? If you know it, can you be able to estimate the distance between any 2 given points? Because they can give you the map and they ask you to estimate the distance between the 2 given points. So that is what we call the equations of lines and curves. Even they can give you a curve and they ask you to estimate the area. So you must know it. Number two, you'll find things like what we call algebra. Algebra, every day you apply algebra. When you go to buy things, when you are counting things and you are dealing with algebra, you are dealing with numbers. So that is another topic under this patterns and algebra. Another topic I want you to give attention to is what we call mappings and relations. Or every day you are in kind of relation, you are connected to someone. You are connected to your friends in school. You have friends you talk to in school. So you are having some kind of relation. And therefore, it means that topic can easily be set. So we can easily set something of that nature. We can also have what we call vectors and translations. But the most common one that you must give attention to is what we call linear programming. And then the other one is going to be what we call loci. I know you may not have covered loci fully. It will depend on your school coverage, but this one is a common one. More so if at all it comes to construction, it comes to inscribing, it comes to circumscribing, then you need to give it attention. You need to give it attention such that we don't, and therefore today our concentration is going to be on what we call linear programming. And when we feel that everyone has mastered linear programming, and therefore we shall continue to go to the next thing. Okay, so our concentration today is going to be on linear programming. We want that by the time you leave this session, when at least you can do a number on linear programming. All other topics under here, such as quadratic equations, simultaneous equations, inequalities, they are going to be easy for you if you can be able, if you master linear programming. All others are going to be, because this is one of the topics we have found like students getting challenged with. And therefore, we are going to concentrate on linear programming in this session. And we want that by the time you leave this session, at least when each one of you can at least get or score a 10 out of 20 on that number. If God is with us and that number appears for any of your mock exams, at least we want to ensure that you go out with the 10 out of that 20. So that is where we are going to concentrate on. And therefore, after that, we shall go and look at the data and probability, geometry, and measures. But I want to let you know, we are going to, in case of you have any question concerning linear programming, concerning patterns and algebra, this is the session where we are going. So we are starting with the compulsory items. We know that item number 1 and item number 2 are compulsory. So are the ones that we want to start with, give them much time, and see that our children, that you pass highly when it comes to those numbers. Now, allow me to welcome, okay, yes, okay, I think, yes, Teacher Samuel, kindly unmute. Teacher Samuel, kindly unmute.
Hello, sir.
Okay, you are clear. Let me spotlight you. Okay, very good. We are good to go.
Thank you. I would like to take this opportunity, first of all, to apologize for the delay. We will have challenges with our internet connection here. Nevertheless, we thank God we are back. Good afternoon, and good afternoon, students. My name is Teacher Samuel Chirabe. I teach at Wanyan Girls Secondary School, and I would like to take you on linear programming. Linear programming is our concern today, but we need first of all to know where this originates. That is the theme. The theme under which the topic linear programming originates is patterns and algebra. The theme we have here is patterns and algebra. And under this, we shall be interested in our learners' competence. By the time we complete learning linear programming, what exactly can the learner do? The learner should be able to handle problems of real life using the knowledge of linear programming. However, before I go into teaching what exactly linear programming is, it is good to know why learn it. So we need to look at the application of linear programming in real life situations. Linear programming is so much used in manufacturing and production in determining how much of the raw materials should be employed with the care of maximizing profit and minimizing losses as well as costs. Even in diet optimization, linear programming is very important for the farmers more so. If they are to use the food for the animals so that they maximize the weight. For example, if you are rearing pigs or chicken, you need to look at the best option, the quality food, which will bring up the best weight so that you maximize the output. So diet optimization is very important also. Then the use of transportation. Linear programming helps us in solving transportation problems. Here we know we have a particular number of students, for example, who need to go for a geography excursion out there. We want all of them to move, but we want to use the limited resources carefully so that we are not wasteful. Moreover, with all of them moving, linear programming comes into play. Then workforce scheduling, knowing how many employees in a particular department should I employ so that they work best. Moreover, at minimum pay or minimum cost. Workforce schedules, there are a lot of schedules we need in a workplace. Even here at Wanyang Girls Secondary School, we have so many departments. We have groundsmen, we have people who are learning teaching, but they help us in the offices. We have security, we have the staff. Linear programming helps us to know how to optimize, how to get the best number to work where. For example, even the staff, we look at the number of students vis-a-vis the number of teachers. Linear programming comes into play in workforce scheduling. Then we also look at research scientists like engineers. They employ linear programming so much. To mention but a few, linear programming is very useful. But then, what is the linear programming? It's a method used to solve problems in life and ensuring that we find the best solutions to conditions. You know, linear programming involves conditions. There are restrictions. Why bring in restrictions? It is because of the limited resources, limited finances, limited space. For example, if we are talking about land, we have limited land. Moreover, we want to utilize it and gain income. Even the number of, for example, vehicles we are to use as a school could be limited. So because of limitation of the resources, we are restricted. We are constrained. You want it to be this, but you are constrained. So linear programming comes in to help us solve those challenges of limited resources so that we use what we have, little as it may be, but finally we come out with the best. Now, when we are looking at linear programming, the main aim is to minimize profit or income at a minimized cost. That's the main aim. So as we study this, you need to take time to discover how is the cost going to be minimized and how is the profit going to be maximized. Still, before we go into the real gist of the matter of linear programming, there are key words which are important for us to revise. I know right away from Form 2, you've learned about inequalities. Now we want to employ that knowledge of inequalities in handling issues of linear programming. There are key words which I want to interest you in. Keywords like keywords in linear programming problem. For this
Teacher Samuel.
solution,
Teacher Samuel.
Hello, dear.
Yes, I'm asking, let the cameraman get a bit closer to the board.
All right. Yes, how is it now?
Okay, I'm just there's something that's not clear. I don't know whether we can. There's something not so clear. I don't know.
How is we are trying. Let's try
Okay.
until we get the best.
Okay. Like, can we first clean the camera? I don't know that is the camera.
Oh. Let's try to clean the camera. That bit does relate.
How about there?
What about there?
Yes. Can we reduce on the light, I think, in the room also?
Oh, you people help us and give the light. Where are you passing? We are reducing the light. You try to cover those windows. Let's be fast.
Yeah.
Most of that window there. Like that door. We are very sorry. We are taking time. Your internet connection is asking. Fine. Now I can go. How is it now? It's still not clear and the handwriting.
Here it not appear clear.
Okay.
Here.
Okay. Don't switch off. Don't switch off. You're already complaining about. Could be brighter with the light. Okay. Hello. Hello.
Let us first continue. But I'm going to request, is there someone with the phone? Maybe he can connect as well on the phone.
Okay.
Yeah.
You try to connect on as well.
Okay. But let us continue.
I was looking at the keywords that we need to revise in order to handle linear programming very well. One of them is the at least case. At least. Then we have the greater than or equal to. And then we have not less than. Not less than. Now, when we look at all these three, we need to realize that if we say at least x, the list will be x. Greater than or equal to, it means that actually the list is still going to be that x. because we are saying greater than or equal. Let's say at least x. That means the list is x. Greater than or equal to x. We shall end up still taking x as the list and not less than. The implication is that the list is still x. Anything below it is not in play. So the implication is that for all of these, we shall have the same. So for example, if it says at least x, we can even say at least 5. Not greater than or equal to 5. Not less than 5. So if we assume a certain variable x for Roman 1, you will discover it's less than 5. We say at least, the list is 5. It means it is greater or equal to 5. So we shall write this. Then when we say greater than or equal to 5, this is already the same. Not less than 5. It means it's from 5 and above. Same. So all of these three, we shall have the same constraint, constraining us that we must start from 5 and above. So we need to take care of the three cases, which mean the same. There's also this other similar case of at most. There's this other case of at most, part B, at the most, let's say at the most 5. Then we say less than or equal to 5. And then we say not more than 5. Now, if we pick on a certain variable, y, say y, and we say at the most, y is at most 5. That means it is either less or equal to 5, because the highest is 5. Now, if they say less than or equal to 5, the same inequality here, not more than 5. We are moving all away from 5 and below. So it means all of these three must be considered carefully because they mean the same. Now, there are also others like we say between. We need to take care of between, meaning it is lying within a certain range. Say x is from A to B, not inclusive, that x is greater than A, the same x less than B. That is between. And then D, exceeding. These are languages we can find in linear programming, which you must take course and know before we can study linear programming. We say exceeding, this implies greater than the given number. This just means greater than the number given. Yes. Keywords, which also are very important in linear programming, like linear programming itself. What is the point?
Ask the second one. We think that this factor x is possible. Then change to the second one.
Second one,
yeah.
All right. Hello.
Yes.
Hello.
Hello?
We are requesting that we change to the second one, Yange, so that we use that to try the phone and see.
Okay. 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 Have you switched on the video for that one?
Yes. Yes, it is on.
Okay. Okay. First switch on. Let me see.
How is it there?
Okay. Let's get a bit near to the board. Okay. Yes. Okay. Okay. At least we shall go with that one. Yeah. Okay. Yes. Okay.
Let me change the camera.
So we shall look at use that sound.
Now let's disconnect one microphone.
Yes.
Disconnect one microphone. Okay. Okay. Let's continue.
Yes, linear programming, we need to look at more keywords in the language of linear programming. The very first one is linear programming itself, which we had already in the definition. But the most important thing is for us to realize what it is. And one thing we know is that linear programming is actually a way to solve day-to-day problems in business and industry by expressing the conditions, the limitations, the constraints in linear inequalities. So this one is directly taken into linear inequalities, and then we are able to graph and solve. So we employ linear inequalities as per the information given, and then from the linear inequalities, we are able to graph and get the best solution depending on the feasible region. Another point we need to look at are the objective functions. A linear programming problem, we expect to have what we call the objective function. This first one was the linear programming itself. We also have what we call the objective function. As we solve this problem, we have always an objective, and there is a function for this objective, either to maximize or minimize. At times, we term this as the optimization expression. So we shall also need to know what an objective function is. And objective function is always in the form z equal to a plus b1, where a and b are constants. A and b are constants, and x and y are variables. They vary depending on the solution set we shall get from the feasible region. That is what we call an objective function. We need to get used it what it is. On the other side, part C are the constraints. The constraints constrain us from not going above, from not going below, depending on the conditions we are given. These constrain us. These are the limitations or restrictions. These are the limitations, restrictions. The limitations and restrictions are the ones which lead us into employing the inequalities. You see us using that, using that, using that, using that, less or equal, depending on the limitations and restrictions. Like I said, it is because of the limited resources we have. Then the other part, D, is the feasible region. We need also to get adapted to what we call the feasible region. And normally denoted by letter R, uppercase R. The feasible region is that region with a set of coordinates which satisfy all the system of our linear programming problem. You know, we are going to get systems of linear programming problems from which we shall get equations. So the feasible region is that region of set of coordinates which satisfies all the systems of those equations. That will be the feasible region. Part E is the optimization. Optimization. This is another term we need to take care of, but simple optimization is minimizing, maximizing. And when we consider minimizing, we want, as business people, we want to minimize the costs or losses. And when we talk about maximization, it is normally with income and profit. We want to maximize income as well as profit. So we shall have the optimization as a term, but this employs the objective function for us to be able to optimize. I said optimizing, it is either minimizing and minimizing with respect to costs. And it can be maximizing with aim of maximizing income as well as profit. That is the aim of business people. They need to make profit so that they can have continuity. Now, this optimization can be done in two functions. Objective function. It is the objective function that we use to maximize or minimize with respect to what? To profit. With respect to what? To cost. But using our objective function. This is what we use to optimize. But in using it, there are basically two ways. The first way, after we have come up with the linear programming graph, we shall look at the point which is farthest from the origin. It will be able to maximize our profit. To maximize the profit. And then we also look at the closest point will be able to give us the minimum out. Method one is by drawing what we call the search line. We draw a search line. A search line, although this is not very common, at O level, most of the time we check for this. But if we are interested in learning the search line, I know our teachers can lead us through, because if we draw the search line, which search line also comes from this optimization equation, we draw a search line, and when we shift, we keep shifting the search line. If our search line is same, if that is our search line, Z. If we shift it away from the origin, the last point it will leave us, will be a maximizing point. But if we move in a parallel way towards the origin, then the only last point we shall remain with towards the origin will be the minimizing point. So we can use this because it's not very common for all levels. The steps involved in solving linear programming problem. I requested that for linear programming. If you are to ensure a programming problem, you better follow these steps. You will not risk, you will not have challenges. The first step, A, is what we call the unknowns. Ask yourself, in this scenario, what are the unknowns? What are the unknowns? What are the unknowns in my scenario? So you have to read, but carefully, and relate the given information, and then discover what the unknowns are. And normally the unknowns will be named with variables. And because we want to use the Cartesian system of graphing to plot and then graph, we our unknowns as X and Y. So you must discover which are the unknowns. And then system Y is asking yourself, what are the conditions? What are the constraints? What is constraining me in my expenditure? What is constraining me in utilization of these resources around, the buses around, in utilization of teachers so that we can have, you ask yourself, which are their constraints? And then part C is what is the objective function? We've already seen what an objective function is. So you ask yourself, what is the objective function? What is the objective function? Because the objective function is going to help us in maximizing profit and minimizing losses or costs. Those are the major three steps we shall get going as we find solutions to our LPP. Now, there are problems, linear programming problems we had in our first virtual O-level seminar. I picked on item number 3 and item number 8 so that we can use it to see that we are able to show you what we are talking about, employing item number 3 and item number 8. I'll first show you item number 3 so that you see. First of all, we shall have the question. Can you repeat this question very fast? First of all, we shall have this question. And this was item number 3. Item number 3 read, your uncle owns a small bakery and plans to bake 2 types of loaves of bread, whole wheat bread and white bread. Due to the bakery's oven capacity, the bakery's oven capacity, this is already a constraint coming our way. Your uncle can
Teacher Samuel? Teacher Samuel?
the restriction coming your way.
Teacher Samuel?
Yes, narrowed.
Teacher Samuel?
Hello, dear.
Yes, let me display it from this side. I'm saying,
yes.
Let me display it from this side.
Oh, thank you.
Okay, and then you read from here.
All right. Yes. So we are saying that your uncle owns a small bakery and plans to bake 2 types of loaves of bread, whole wheat bread and white bread. Due to the bakery's oven capacity, your uncle can make at most 15 loaves of bread in a day. You want to bake at least 3 loaves of whole wheat bread. Additionally, he wants to bake more whole wheat bread than white bread because it's more popular among his customers. The selling prices are as follows. Whole wheat bread is sold at shillings 6,500 per loaf. White bread is sold at shillings 5,000 per loaf. To cover his costs and make a profit, your uncle needs to earn more than shillings 30,000 from the sales each day. Then we have the task. Part A, write mathematical statements that show the relation between the whole wheat bread and white bread. Part B, show the feasible region of the relation on the Cartesian plane. Part C, how many loaves of each type should your uncle bake in order to make the maximum profit? And finally, part D, what is the minimum number of loaves he can bake and still make profit? When you look at this question, you see that the information given here is a real life information, and it can help us to handle our task easily. First of all, if you look at part A, they are asking us to write mathematical statements that show the relation between, please share the question in the chat. They also need it. I think we can now share. Yes. Thank you so much. That is our question. And if you look at our question, the task can easily be handled depending on the case to write mathematical statements that show the relation between the whole wheat bread and the white bread. Now, the first thing we shared about the steps to solving these scenario problems on linear programming. I did say that the first step is to discover the unknowns. And this particular case, we need to look at the unknowns very carefully. If you look at the information again, you'll see the number of whole wheat bread. The number of whole wheat bread will be one of the unknowns. They say 2 types of loaves, whole wheat bread, this one, and white bread. So we are going to consider the number. We are going to consider, let's come this side. We are going to consider, first of all, we are going to consider the unknowns. Our unknowns in this particular case is 1, the number of whole wheat bread. That is our first unknown, and since it's the first one, oh, you want to get the question?
No, I think they have the question.
They have the question.
So tell them open so that they can follow.
So members can look at the question so that you can easily follow. Yes, you can copy that question so that you can easily follow. We see that the number of whole wheat bread is one of the unknowns, and since it is appearing first, we can take it for X. And then the other one is the number of white bread. Number of white white bread. This we can take for 1. That is part A already done. That was our first step. Second step is the constraints now. What constrains us there? We are told that due to the baker's oven capacity, your uncle can bake at most 15 loaves of bread in a day. Now that is the condition. Cannot bake more than 15 of both types. So we can get one of the statements as one of white must be less statement there. Then there's another one here. If you look at the information, additionally, he wants to bake at least 3 loaves of whole wheat bread. Additionally, he wants to bake more whole wheat bread than white bread. So he wants to bake at least 3 loaves. So the list should be 3 loaves of whole wheat bread. Whole wheat bread was the X. So if they say at least 3, it means it can be 3 or above. So we shall say X greater or equal to X greater or equal to 3. And that will be our second statement. The other one, he did say that additionally he wants to bake more whole wheat bread than white bread. Whole wheat bread was X. So we shall say X greater than the white bread, which was Y, as our third constraint here. Then there are those usual ones. Since we are looking at number of items, there is a possibility to condition yourself to baking either no whole bread. That is the usual constraint which you should never leave out. So this makes the 4th one. And then also for white bread, same way.
Talk to them, talk to them.
Now, my attendants, those who are attending to this lesson, I request you, if you're a student, to request from your teacher to get this item. Because in the first virtual seminar we had all these items provided to us. You can pick those questions and we use them easily. Yes. Or if you have a phone, you could even save it as we are trying to share it. You save it immediately. My friends, try to share it so that they can see. You save it and then you use it. Because you need to use it as we write down the constraints and even the following solutions. We shall need the problem itself. Okay. Back here, those are our constraints. And then the next thing is writing down the objective function. The objective function, we are told that whole wheat bread and white bread, because it's more, yeah. We are told that the selling prices are as follows. Whole wheat bread is sold at shillings 6,500 per loaf. White bread is sold at shillings 5,000 per loaf. So these are costs which can help us in getting the sales or the total selling price. To cover costs and make profit, your uncle needs to earn more than, there's now another condition here, that for him to make profit, he should earn more than 30,000 from the sales each day. So as we care of this condition here. So the objective function Z, in this particular case, it is representing the sales. You can use Z or you can use the letter cell because we are going to take up sales. So you'll say the sales equal to the 6,500 per each loaf of white bread. And for us to get now, this is the sales equation, but we are interested in optimization expression or equation. For us to get the optimization equation, which will lead us to profit, we need to take care of the 30,000 there. So for us to be able to take this as a profit now expression, we shall have to add on the 30,000 because we are told it should be more than the income by 30,000 shillings. So I'll take this income, the total sales is this income plus 30,000. There we shall be making the optimization expression and particularly for profit. So that will be our optimization equation. Now, that is part A. That was part A, and that was part B. That was part B. When you look at this, it says part B shows the feasible region. Part B is asking for the feasible region. Part B is a level of showing the feasible region. The feasible region, like we said, is the unshaded region. After shading the unwanted parts of every inequality, we shall remain with the intersection region, which is unshaded, satisfying the system of our constraints. So we need to go to that level. Now, this will involve taking care of each of these constraints by changing these constraints from inequality to a line. Remember, we need to formulate the linear equation. When we formulate the linear equation, then you are able to plot and come up with the feasible region. No, we shall need that. Let's come back.
So first wait.
All right.
Sync video.
So,
I think that is okay.
yeah. Now, for this particular inequality, we shall have this as the equation, for which equation we must get some coordinates to plot in terms of x and y, and then we plot and shall be there. When tracing for the points to plot, it is good to discover the intercepts. At the y-intercept, we shall have x as 0. And at the x-intercept, we shall have y as 0. We'll be able to plot. But you need also to take care of the nature of line. That and this depends on the nature of inequality you have here. Since we have less or equal, we shall draw a full line. And So if we want to plot this equation, we shall get some points to plot. And it is good to check at the intersection points. Where does this line intersect? We intercept the y-axis. As it intercepts with the y-axis, we shall have x equal to 0. And as it intersects with the x-axis, we shall have y equal to 0. Those are very important points. You can add on a third point, but with your long ruler, even these 2 points can suffice. And then you draw a full line. After drawing the full line, we shall go to a level of testing to see what exactly. You can look at this graph. We have already drawn this graph, and we are looking at this as being our first point, 0, 15. There. And our second point is 15, 0. That point there, you can even use 10, 5. There's a problem with this. So, okay, the next point was 10, 5. Yeah, 10, 5 is there. Yes. So you can draw the line. And my students, you need to be careful. We see very many diagrams which are hanging with hanging lines. A line does not cross the y-axis, does not cross the x-axis. That's not good. Permit the line to flow so that it crosses the 2 axes. There you will get the direction of the challenge properly. Make sure it crosses the 2 axes. Then we run to the second one. The second one, the inequality was x greater or equal to 3. This was our inequality. And then from it, we get the line x equal to 3. And this line x equal to 3 is basically a vertical line through the value 3. So we draw that vertical line. And because of the nature of the inequality greater or equal, it's going to be a full line. You draw that full line there. And then after that, there is also the third inequality, which is x greater than y. For x greater than y, we shall have x equal to 1. That x equal to y because of the nature of this inequality. This inequality is greater than, we shall not have a full line. We shall use a broken line and we draw. That broken line, if you organize the table of values for x and y, you organize that, you can say 0, 0, 15, 15, and many others. So if you plotted it, you'll have it going through there, and that will be x equal to y, taking care that it's a broken line, depending on the nature of constraint we had there. Then the other two, the x greater or equal to 0, I think this was the fourth, and the x, the y greater or equal to 0. This was the fifth. The x greater or equal to 0, its equation will be x equal to 0. X equal to 0 is the y-axis. So we are supposed to label this as x equal to 0. But this constraint is already covered. If you look at it carefully, that constraint is covered by x greater or equal to 3. So you don't need to plot it. It is already taken care of. And then the y greater or equal to 0 will be the x-axis. This y equal to 0 is the x-axis here. And it is going to be a full line because of the nature of the inequality. Now, after plotting and drawing those lines, we now had the first line. We need to take care to see what to shade of the first line. Remember, our first line was x plus y equal to 15. So we go and test. We need to test. We need to go at the level of testing. We are going to test what happens from this inequality, we want to test to see which is the suitable region that we can shade the unsuitable region. We are going to test all through the inequalities. The first one was x plus y less or equal to 15. But at testing level, this is now testing. We are going to test certain points, testing points. We are going to test certain points. At the testing level, the first thing we look at is we drop this equal sign. Why drop it? It has been taken up by the line under play. That line called x plus y equal to 15 takes up all the stable points along it. So already this part is taken care of, the equal to 15. So we don't expect to test using less or equal. We are going to test using x plus y less than 15. Now in testing, you go back to your Cartesian plane here. This Cartesian plane shows that when we draw the line x plus y equal to 15, the plane is now into two parts. The part on the right hand side, or the part above the line, and the part below the line. This is the part above, and that is the part below. So you are free to check any of the two parts to see what to shade. Normally, it is wise to use low value point through the origin. You can easily use the origin, which origin is 0, 0, as your point to check. So we are going to use point 0, 0. So you substitute and say 0 plus 0, is it less than 15? Or 0 is less than 15. It is true. Now, if it's true, it means that where this point was picked is a wanted region. And remember, we shade the unwanted region. So we go ahead and shade the upper side and leave, we shade the upper side and leave the lower side unshaded because that's where we picked the point 0, 0. That said, it takes us now to the next line. Remember, our next line was x equal to 3. But don't forget that x equal to 3 originated from x greater. The speed still. I try to lower. Okay, I'm going to lower the speed. Yes. I want now to look at graphing the x greater or equal to 3. Remember, this is our second inequality. Now we want to see which side of it to plot, to graph. But don't forget that we drop the equal sign and now just check the x greater than 3. Because the equal sign is taken care of. So we are going to check on that line, where is, which side is x greater than 3? Don't forget, this vertical line has divided our plane into two. The one on my left and the one on the right. So you are free to pick on any point and use it to check whether x is greater than 3. Any point, you are free to pick on any point. Now I can pick a point here. This point is 6, 5. If I pick on that point there, it is on the right-hand side, 6, 5. And here, x equal to 6 and y equal to 5. So there, x is already, if I pick on point 6, 5, that point there, testing it, I see that actually 6 is greater than 3. This is true. Now, if it's true, the implication is that where I pick the point 6, 5 is a wanted region. So I shade up the other opposite side. So this is a wanted region. That's why this side is shaded. Now, we also look at the x greater than y. The next constraint was x greater than y. So our x greater than y gave us the line x equal to y. X equal to y also gives us two regions, the one below and the one above. And you are free to pick on any point. But this particular case, this line goes through the origin. Take care not to use the origin. Take care not to use the points on the line, but you are free to pick on any point. And any point I can say, I can even use the first point I used. I'm requested to repeat this part where I have x greater than y. Don't forget that since we are checking, we are testing for x greater than y. We want to test. So when you pick on the points on the side below or the side above, any point, I can even pick on any point this side. I'm going to pick on point 510 here because it is above the line. I'm going to use the point 510 this time so that I make a change. I'm going to use point 510. 510 means the x value is 5. Is it greater than the 10? Oh, this is false. This is false. If it's false, the implication, since this is false, the implication that the origin of this point is not a needed region. So I'm going to shade it. I'll shade the area where I pick the point 510. So if we come to our graph, we shall shade here. Don't forget this is where I picked the 510 from. I'll shade that region. That's why you are seeing it shaded. Finally, we have the other two, the usual two. We also need to check them. We are going to check x greater or equal to 0. But this one we say it's already covered. You don't need to waste time on it. It was taken care of the x greater than 3. So we shall only need to check for y greater or equal to 0. And this particular case, I told you to test, don't use the equal sign. You drop the equal sign and use for greater than 0. So on that line, don't forget this is the y-axis, the x-axis. Go and check the x-axis, which is this, which is y equal to 0. And your interest is for y greater than 0. So when you plot this, pick on any point, like here. When you pick on any point above, any point you pick above that x-axis, you'll see that all the y values are greater than 0. For example, here, the y is 1. Here, the y is 2. Here, the y is 3. Any point you pick on, here, the y is 2. Anywhere you pick, even if you go this side, the y is 11. So any point above is satisfying our inequality. We shall shade below, because what's below is actually less than 0. So that will be what we shall have. And then we shall remain with this as, we shall remain with this as our feasible region, which we normally denote by letter R, uppercase R, as the feasible region. That is our feasible region, from which the 3 main inequalities for this and that, then plus the other 2 intersect. So this is the area which is the solution to the system of the 5 inequalities which we got there. In here, we shall get the solution set to all the 5 systems of inequalities. And if we wanted, you go ahead and Write down all of these integral points. If at all they are demanded for, you write down all the integral points which are within. But you take care to involve even the points which are lying on the full lines, provided they are integral points. Like these points here, you will take care and carry them on. But if you reach a point like this, much as it is an integral point, because it is on a broken line, it doesn't satisfy our solution. So points which are on the dotted line are not part of our solution set. Okay, so that is the physical region which we are interested in part B. Show the feasible region of the relation on the Cartesian plane. That is it. In part C, we are asked. In part C, we are asked, how many loaves of each type should your uncle bake in order to make the maximum profit? Now, this is the level we are talking about optimization. Yes, in our steps, we saw step 3 is that we have to get the optimization expression. And don't forget, we already have our equation for optimization. We just need to put it down, but take care to see of that set, that big set of solutions, which shall we use to maximize? Like I did say, these vertices are very important. Don't forget that this region is solving a system of equations now. There is equation x plus y equal to 15, x equal to y, system y equal to 0, system x equal to 3. So the vertices of intersection where the two lines intersect are very important to us. So as you look for maximization points, minimization points, take care of those vertices, the vertices. They are very important. Like a vertex A, that's why I now demarcate it as a point of interest A. Then I demarcated this as also a point of interest B. Then this would be a very good point, but the challenge I'm getting here, there are no integral values here. The second challenge I'm getting here, this line is a broken line. So this is not required, but I go close to it. I suspect it may be useful to me. So I will check point A, point B, point C, since they are the vertices, these are vertices, and this one is close to the would-be vertex. So those are the points I will check to see that I come up with my minimization, maximization points. Now that's it. And to summarize this so that you can easily get it, we made a simple table here where we have x and y values from the points, and then we have our maximization, what did we call that? I was changing some of these things. I think I called it P. I think I called it P. It will be 6,500 x plus 5,000 y plus the 30,000, you remember. So we make a simple table here, and that table will be filled in. I told you the first point I'll check is A, and it is at 30. The second point I'll check is B, it's at 15.0. And finally, we shall have C at 8.7. Now, for X is 3, 15, 8. The Y value here is 0, 0, 7. Now here I substitute. I'll say 6,500 times the 3, the X value, plus 5,000 times the 0. Now plus the 30,000. plus the 30,000. And here, the value will be 49,500. The value we are going to get here. Because of space, I'm going to, we can remove this. I would like to extend this table so that it takes up all our content. This is going to be 49,500. And then we shall have to check this also. We shall have 6,500 times 15. Because of the zero, permit me to put zero here. Plus the 30,000. And we shall end up with 127. You go back to the shaded area, leaving us a feasible region. We pick them from the feasible region. There are quite so many, but to save time, you go at the vertices, because the vertices are the solution sets for all those lines drawn. So you pick on the vertices, they will help you to get the points to optimize. We pick these points from the feasible region. But you also take care not to pick those which are crossed by the dotted line. And don't forget, pick only on integral values. Integral values are the full number values. Because here, we are talking about number of items. We shall not go into those decimals. All right. Now back here, we shall have 6,500 times now the 8 plus 5,000 times now the 7. Again, plus the 30,000, because it should be 30,000 more. And here we shall end up with 117,000. Now, by the way, this is in shillings. So now, if you look at the outcome from our points, the 3 points, and you are interested in maximizing, for him to make maximum profit, you look at the highest profit he made. It can't be 49,500. This is 127,500 as the maximum. So we shall check that as our maximum profit, and then advise him on what to use, depending on the point B. Shall use point B, which is 15, 0, with x equal to 15. So we are going to advise Uncle to ensure that he only bakes 15 whole wheat bread to maximize profit. Uncle should only bake 15 whole wheat bread. If 15 loaves of whole wheat bread to maximize profit. Yes, remember we wanted to see, to solve a problem. He has a challenge of what is the best to produce or to make, to bake in this particular case, to see that we will get the highest profit. And we have discovered that for Uncle to get the highest profit, he needs only to bake one type of bread, and that is 15 whole wheat bread, 15 loaves of whole wheat bread, and their weights there. Yes, somebody is asking, where did the 30,000 originate? The 30,000 originated from our item. The item said to cover his costs and make a profit, your uncle needs to earn more than shillings 30,000 from the sales each day. For us to ensure that he earns more than shillings 30,000, we ensure that on our sales, we make it to be more than 30. And the only way to make it more than 30 is by adding on that 30,000 shillings. The sales equation was, don't forget, this was the sales equation. S was 6,500 X plus 30,000 Y. That was the sales equation. So for uncle to maximize profit, for uncle to get profit, the sales must be topped up with that 30,000. That's why we say now we shall have the profit equation as 6,500 X plus, yes, plus 30,000. What's that?
Supposed to be 5,000.
This was 5,000. That's that. This was 5,000. So here we are going to have the 5,000 Y now plus the 30,000. That's how the 30,000 is coming into our profit. It originated from the item. Thank you. Now, if you look at the item, Part D wanted us to find the minimum number of loaves he can bake and still make a profit. So when you look at this, don't forget, I told you that those vertices are very important in optimization, minimizing or maximizing. So for the case of minimization, we still go to our points. Don't forget that this point was closest to the origin, point A. And you check and see, is it giving us the list? 49,500 is the list of this profit. And it is closest to the origin. So that point is a minimization point. So for him to minimize the profit, you will have to bake 3 whole wheat loaves of bread only. Yes. So we can say part D. The minimum number of loaves you can bake and still the minimum number of loaves we can bake and still make a profit. Is 3 loaves of whole wheat bread. That is it. If he makes only 3 loaves, he will still make profit. If you relate this 49,500 and the condition was that he must have more than 30,000 before he makes profit, we see that there is still profit there. Yes, thank you so much. This item ended with part D. we need now to look at item number 8.
Okay.
I don't know whether
Teacher Samuel?
Yes, please.
Yes, it seems I'm saying, can we pick 2 questions?
Yes, there are 2 questions.
Okay.
Oh, there are some 2 questions there.
Yes. Okay.
It's fine here.
Central College Kawala. Is it a question? Okay. St. Elizabeth Girls.
Okay, sir. How did you plot the coordinates for equation 1? Because I see there are 3. And why are the points in a dotted line not part of our solution set?
You are asking about the number of inequalities plotted. Let me start by answering the second question, because the second question was very clear. Why is it that the points on the dotted line are not part of the solution? The points on the dotted line are not part of the solution because they originated from the inequality x. Can I list those inequalities towards x what?
Yeah.
X greater than y. So if we have a broken line here, the points there are not part of the region. The points here are not part of the region because of the nature of this constraint. It is telling us that x should be greater than y. So we cannot involve the points on that line because the line is going to be x equal to y, but a dotted line. Because of the nature of this point, they are telling us it should be greater than y. X should be greater than y. Points lying on that line cannot be part of the solution. But here, it is part of the solution because the full line, the fullness of the line shows that our feasible region starts and involves that line to the region unshaded. The dotted line shows that the feasible region reaches but does not involve this broken line. So points on the broken line are not part of the feasible region. That's why we don't involve them in our solution. The origin of not involving them is the nature of our constraint. It is constraining us that x should be greater than y. Had it to be that x is greater or equal to y, and we even draw a full line to involve that all the points lying on that line are suitable. But in this particular case, it is x greater than y, meaning that the points lying on that line are not part of the solution set. Then I request you to pardon me with the issue of how many lines we shaded here vis-a-vis, I think, the inequalities we had. Could you pardon me and I answer that?
Okay. I was like, how did you get coordinates for equation 1 and how did you plot them? Because I see there are 3 coordinates.
Oh, all right. Now I got the coordinates of equation 1. Our equation 1 was x plus y equal to 15. X plus y equal to 15. And if you look at our table, we had a simple table here for x and y, and we organized the intercepts 0, 15, 15, 0, and 10, 5. Then this is what we had. So on plotting these points, I had 0, 15. 0, 15 would be a point here. Then 15, 0. 15, 0 would be a point here. And then 10, 5, 10, 5 is a point here. So I connect with a long ruler with a full line and I draw that line. That's how I drew. You You can even see my crosses here to demarcate the points plotted. Those are my points I plotted. I connected them with a straight edge and came up with that line. That is how the whole thing went.
Wilbach's.
I hope we are at par.
Yes, there's someone who wanted, but is failing. Wilbach's. Okay. Then let's Kanjuchi.
I was asking.
Yes, please.
I was asking that they asked for the maximum points for both. The maximum for both, for each type of the product. And I was suggesting that it would be 8-7 and not 15-0, because 15 works for only X and 0 is not, and the Y part is not catered for 0.
Oh, number 0 as catered. If you look at X equal 15, the number X is catered for as 15. These are still 15 loaves of whole wheat bread. And the number Y equal to 0 is also catering for the white bread. Don't think that the white bread is not catered for. It is catered for as 0. And in the real sense, it means we shall put off that and only make the whole wheat bread, 15 of them. Yes, this 0 is meaningful. I don't know whether I've answered you. Even my other colleagues, the teachers, will come in to help us there, but that's what I think. That 0 will help us to maximize the profit. You were talking of 8 and 7 somewhere, all right? 8 and 7. We could check it. Let's check 8 and 7 and see. What do we have for part C? 8 and 7 is the maximum. It is 117,000 compared to 127,500. This is less. Yes. So the maximum would be best at level 15 for whole wheat and 0 for white bread.
Hello.
Okay. I think, yes, Mr. Samuel, let me display for them the solutions you came up, such that those students who are not able to see well can be able to take screenshots.
Thank you, sir.
Okay. So those who are not seeing properly, kindly take a screenshot. Yes, and you can clearly see that the OR is the first thing, like we said. Make sure you label your unknowns. Define what your unknowns are. Like what teacher Samuel did. Number of whole wheat bread is X. White bread is Y. And do not forget to define your objective function whenever they ask you to have the mathematical statement. So all these ones are awarded depending on how you have written them. So do not forget to write also the objective function, because it is also a mathematical statement. Okay, so you take the screenshots in case you were not able to see them very well. Yes. For those students, Mr. Samuel used this approach of the intercept form for this part. But in case those students who are finding it hard, like one of you asked, for you can decide to plot a big table, though it will take you some time. Like you can see that you had X plus Y is equal to 15. Now you can see this is my X and this is my Y. In case you want, you can first form your equation of a line by making Y the subject. So you say X minus X plus Y is equal to 15 minus X. then you say y is equal to 15 minus x. Then you can decide to obtain the different values of x. Let me say you say x is equal to 0, x1, x2, x3, x4, and so on. Though now this one will take you a lot of time than someone who has used the intercept format. So then you start substituting. When x is 0, I'll have 15. When x is 1, then you say 15 minus 1, which gives us 14. So you get 14, here you'll get 13, you'll get 12, something like that. So you can decide to use that approach. Also, it can work. Then now for this one to be very accurate, you need very many values. But in case you decide to use the intercept form, because we know very well that one of the easiest thing to do is whenever you have a line, the moment you get an intercept, we say that an intercept is that point where your line cuts any of the axis. In case it cuts the y-axis, we shall call it the y-intercept. In case it cuts the x-axis, we shall say the x-intercept. So now, if you can only obtain these points where your line cuts, then it means that it is very easy for you to draw that line. And that is the best approach, the easiest approach that can bring for you a line. You just know that for the x-intercept, my y will equal to 0. So you come where there is y, you put 0. So you say x plus 0 is equal to 15, x is equal to 15. Mean that for that case, your x is 15, your y is 0. And then for y-intercept, you know that x is equal to 0. So you go back to your equation, x plus y is equal to 15. Where there is x, you put 0 plus y is equal to 15. Your y is equal to 15. So it means that your coordinate will be 0, 15. So that is the approach Teacher Samuel used. So it is an easy thing because it gives you the accurate answer. So please make sure you use it. Then those who were asking, he answered you well. Please do not forget whenever you find that it is equal, like when we say y is greater than 5. Here, when you are mentioning your solution set, you will say the values I have is 6, 7, 8, and the rest of that. So 5 is not inclusive. So whenever you find that that value is not inclusive, that's when we shall go on and use the dotted lines, like Teacher Samuel has told us. So please stick to that. In case I say y is greater or equal to 80, this one means that any child, in case I compare it to marks, any person who scored equal to 80, here I will bring anyone who has an 80, 85, or any mark above 80, maybe 90. Those are the children that will come. But in case I say y is greater than 80, it means that for you who scored 80, don't come because you are not part of it. But anyone who scored 80, me say 80.1, 80.2, 80.3, such people will come. But anyone with exactly 80, these ones will not appear. So for those ones, we use the dotted lines. But something which has, whenever for you find equal, less or equal, for those ones use a bold line or what we call a full line. And for such, we shall include them on our solution sets. So these are some of the solutions, and clearly look at the graph. Maybe I'm going to comment on the graph. So when you look here, you can notice that we defined our x as the whole wheat bread, and we defined our y as the white blade. So when you come to your graph, please, you can go on and now put instead here, and you say that now this is my, I think it was wheat blade. So you put your wheat bread and come here, put your whole white blade. So I think Opa have labeled them very well. And then after you come up. So this one is what he has called, he has told you it's called the feasible region that satisfies the inequality. But please, since this is the dotted line, do not pick any point along it because he has emphasized it very well. So don't pick any point because it's not part of the solution set. So kindly you can take a screenshot, and that is that we expect you to come up with a graph. And when you are labeling, please do not forget that when you are labeling, use the equation. Like here, x is equal to y. Avoid using things like maybe y greater than x, something like that, or x less than y. Don't use inequalities because these are equations. So label the equation you have plotted. Don't use inequality sign. Stick to the equation that you have been able to do the plotting. So those are the solutions, and we expect you to come with something of that nature. Okay, I think let me end here, and Teacher Samuel, you continue.
We would like now to look at item. The next item was item 8. Item 8 is here. It says a cooperative society of farmers has 50 hectares of land to grow 2 crops, A and B. The profits from crops A and B per hectare are estimated as shillings 10,500,000, this, and shillings 9 million, respectively. To control weeds, a liquid herbicide has to be used for crops A and B at the rate of 20 liters and 10 liters per hectare, respectively. Further, there should be a comma here. Not more than 800 liters of herbicide should be used in order to protect fish and wildlife using a pond which collects drainage from this land. Keeping in mind that the protection of the fish and other wildlife is more important than earning profit, respectively. So this question here is also another scenario question which needs us to employ the technique of linear programming in order to solve it. And the task guides us the steps which will be involved. Part A is telling us to write mathematical statements. Hello, dear.
Yes, let me also display it from here for those who are not seeing it clearly.
All right, sir.
Okay, then you can start from here.
Okay.
We just do that one.
So, task A is write mathematical statements that show the relation between the hectare of land to be allocated to crop A and B, respectively. Part B is show the feasible region of the relation on the Cartesian plane. Part C, how much land should be allocated to each crop so as to maximize the profit. And finally, part D, do you agree with the message that the protection of wildlife is at most necessary to preserve the balance in environment? So straight away, you already remember our steps. The first step is to discover the unknown. Yes, so the first unknown here, we shall take they said a cooperative society of farmers has 50 hectares of land to grow 2 crops, A and B. So we shall take crop A to be the first unknown. Crop A shall take it for X, and crop B shall take it for Y. And at the level of writing the statements, in part A here, we need now to write the constraints. Write mathematical statements that show the relation. So the first relation is the farmer's space they have, the 50 hectares of land. And the 50 hectares of land is going to be shared between type A crop and type B crop. So we can take X for A plus Y for B, which should not exceed the available 50 hectares. And we call that our first statement. Then the next statement is saying, to control weeds, a liquid herbicide has to be used for crops A and B at the rate of 20 liters and 10 liters per hectare. Don't forget that X is representing type A hectares and Y is representing crop B hectares. So we shall now have our next constraint as 20X plus 10y should be less or equal to the 800 liters of herbicide. Further, not more than that, 800 liters of herbicide should be used in order to protect fish and that. When you read through, you see that that is all the information from which you can get the constraints, but don't forget the usual x greater or equal to 0. This can be our third one, and the y greater or equal to 0 will be our fourth one. Good. Now, that is part A. Those are our mathematical statements that can show the relation between the hectare of land to be allotted to crop A and B. Then part B. Part B wants us to show the feasible region of the relation on the Cartesian plane. So part B, we shall come up with the equations from the given inequalities. And here we must have coordinates to plot. We shall have coordinates to plot. And the first one coming from x plus y, let's say equal to 50. The equation will be x plus y equal to 50. And then you accordingly get the points which you are going to plot in this simple table here. Like I said, it is faster to use the intercepts, the x and y intercepts, but you can involve another point and then you plot. So those will be our points. And the nature of line, because of the less or equal, the nature will be a full line. Nature of line will be a full line. Full line. Okay. So we go to Roman 2. We are going to plot that. Roman 2, we shall also look at the inequality there. For the inequality from 20x, the inequality 20x plus 10y, less or equal to 800,000, which is 800 liters. The equation will be 20x plus 10y equal to 800. Now, we need also points there, which we are going to plot. We organize a table for orderliness, and we can use the intercepts as well, and we shall be there. When x is 0, y will be 80, and when x is 10, you can have another value here, y will be 60, and when x is 40, y will be, will be 0. And the nature of line, is because of the less or equal, we shall have a full line as well. Shall have a full line, and then the other two, 3 and the other two, x greater or equal to 0, and here the line will be x equal to 0, and the nature will be still full line. Full line. And finally, 4, we shall have y greater or equal to 0, and this equation will be y equal to 0. The nature will also be full. Then the next level is actually plotting. On plotting, we are going to, first of all, plot the very first one, which was 0.50. 0.50 will be this point here. We have already plotted this, you can see on the chart here. That will be 0.50. Then 25 will be here. and then 50, 0 will be there. You draw that first line for x plus y equal to 50. It is a full line depending on the nature of the inequality, which was less or equal to. And then the second one is this one. The second one, we had points, yes. We had points 0, 80, 0, 80, and then 40, 0. That middle point can also work, but you can easily connect and have it. Then the others, x equal, y equal to 0, and x equal to 0. There are 4 lines here. But now we need to test to see how to shade. For the first line, this line here, x plus y equal to 0. We now run to the level of testing. Yes, we run to the level of testing. On testing, we see that x plus y is less than 50. That was our equality. So we can test using the points. Come up the graph here. We are free to test using the point. There are very many points here because when we draw this line, the upper side, the lower side, you can even test from 0, 0. Use 0, 0. So you use 0, 0, you say 0 plus 0 less than 50. So 0 is less than 50. What does that mean? This is true. This is true. If it is true, it means we are going to the opposite side. We are going to leave where we picked the point 0, 0 from and shade the other side. That's how we end up shading this side. And we leave where the origin is as a wanted region. Then for the second line, we shall also use the origin. Still, it is free. We use the origin and check it. We come here to test. We are going to test for 20x plus 10y less than 800. I told you you have to drop the equal sign because the equal sign is represented by the full line you have drawn. Yes. So we only use this symbol, the less, at testing level. I said we can test with the point, still 0, 0, because it is very easy. When you substitute 20 times 0 plus 10 times 0 less than 800, you end up with 0 less than 800. Wow, the implication is that even where we pick 0, 0 from is a wanted region. So we are going to shade the opposite region. So we come to our graph here. With this line, we shade this other opposite side and leave where the region has 0, 0. Then apart from that, you look at this, at the usual lines, x equal to 0 and y equal to 0. For y equal to 0, we check the condition. The condition is that for y greater or equal to 0, the condition is that y should be greater than 0. So we are going to check where y is greater than 0. And this will be above the x-axis. Will be above the x-axis. And then for x greater or equal to 0, this is going to be greater or equal to 0, greater than 0. We are going to check where is x greater than 0. And here it will be still above the y-axis. Above the y-axis. So you come here and for y greater than 0 is this line here. The line y equal to 0. This line, we forgot to label it, but it's supposed to be y equal to 0. So anything above it is wanted. Because according to our testing, we are interested in y values greater than 0. So we are going to shade those which are less than 0. The same applies here. This is the line x equal to 0. So we are going to shade taking care of where is x greater than 0. According to our testing, we are supposed to check where x is greater than 0. On the right-hand side, x is greater than 0. The side on this side is less, so we shade that side. Then coming up with our feasible region, region R. This region can be showed as R here is said to be the feasible region. That region there, it is the intersecting region for all our inequalities. The system of inequalities is solved by that solution there. So from that level, we are now free to go and look at the next level, part C. Part C. Yes. So we are looking at part C. You look at part C from what our coordinator displayed on the screen was asking how much land should be allocated to each crop so as to maximize the profit. Here we needed to check on the various points which are within the feasible region. But if you check with me, there will be quite many. There will be even more than 10. That's why it is very important now to refer to the points at the vertices of this geometrical figure which we are seeing here. So we shall take care of the vertices. The first vertex is A, the second is B, the next one is C, and then D. For me, I picked on those because I know that is the possible, that's where the possible optimization points are, because we are solving this system of equations using these lines I have used to graph, the 4 lines. So where the line is intercept, it is a solution to those equations. Here is a solution to this equation, the equation representing 20x plus 10 equal to 800, and x and the y-axis, the equation y equal to 0. Solution there. Even this one is a solution to this line and that line. Even this one is a solution to the line this and that line. Even this point is a solution to that line and that line. Those are the best points we can use to optimize. So at the level of optimization, I make a simple table here. Like the other time, we have point A. Point A is at 0, 0. Then we have the X and Y. Then we shall have the optimization expression or equation. And it's supposed to be 10 million, 500,000 X plus 9 million Y. So now, if I substitute the 0, 0, this is going to be points. My first point A is 0, 0. If I substitute 0, 0, I'll get 0. My second point is going to be B at 40, 0. These points are got from the feasible region. Point B is 40, 0. So you carry that for X as 40 and Y as 0. So you shall have 40 here and 0 there. And when you substitute in, you'll end up with 420 million shillings. And the next is C. C is at point 30, 20. 30, 20. And when you substitute the 30 and 20, you'll be ending up with 495 million. 495 billion shillings. And finally, we have point B. Point D has coordinates. Thank you. So D is the point 0, 50. So 0, 50 here. 0 with 50y. And when you substitute, you'll end up with the shillings 450 million. All this is in shillings. Okay. Now, those are the outcomes in our optimization equation there. Now, for us to maximize, we need to look to relate. This is 420 million. This is 495. This is 450. So we see that 495 is the highest. So the maximum profit is shillings 495. How much land should be allotted each so as to maximize the profit? Since the maximum profit is 495,000, you can say maximum profit is shillings 495 million. Now, this is an outcome of 30,000 of crop A and 20,000 of crop B. So we shall answer and say, this is it from point C, 30 and 20. So we shall now make a resolution here and conclude that 30 hectares of land should be allocated to crop A. This one. 30 hectares of land should be. Now, my students, don't write as I'm writing. You write the full sentence and say 30 hectares of land should be allocated to crops A, and 20 hectares of land should be allocated to crop B for there to be maximum profit. Yes. That is it. Then part D, they want us to prove, do you agree with the message that the protection of wildlife is at most necessary to preserve the balanced environment? There is a concern here. Do you agree with the message that the protection of wildlife is at most necessary to preserve the balance in environment? When I was interpreting this with my daughters, I normally work with my daughters, we really exchanged the ideas and we discovered that we needed to first of all look at the case when the herbicides are not If the herbicides are not used, we shall not have this line here, which is talking about the 800. This line is not used, the line for herbicides. It means all of this area would be free, would be a feasible region. So it means we shall have an additional point of 50, and yes, an additional point of 50. Yes, if this is not there. Because if you put in the line of herbicides, it is going to reduce on our region of play for the feasible region. It is going to reduce. So the point which is left out is that 50. So what we have to do is check what would be the profit if we use 50. What profit would be got if we use? We discovered that the profit would be quite more than the maximum profit we are getting here. Let me show you. If we use the point, we can even label this point because we are interested in it. We can label this point as a, we can label this point now as a special point. Point P, let us call it M. That point there. We are now getting interested in it because of the nature of question. Now, if we look at it, it is at 50. M at 50. The implication is that X is equal to 50 and Y equal to 0. So substituting it in our optimization equation, we shall have 10,500,000 times 50 plus 9 million we shall end up with, when you multiply out that, you are going to get shillings 5,025,525. This will be the profit, the constraint of the herbicide. So what is it now? We have to relate it with our maximum profits. You see, our maximum profit maximum was shillings 495 million. We try to get the difference, you'll see that actually shilling 30 million was foregone for the sake of the wildlife. If they had not brought in the condition for the use of herbicides, there would be a profit of 525 million. But after bringing in the condition of the herbicide, it reduced the profit to 2,495,000. So these people had to forego shilling 30 million for the sake of caring for the wildlife. So we can make our conclusion here and say that yes, I agree. Before using the herbicides, the maximum profit was shillings 525,000. This was before using the herbicides. But after the use of herbicides, the maximum profit reduces to 495,000, which proves that the protection of wildlife is more important than the profits. And those, they are giving up with 30 million shillings. So why are they doing that? Because they know the protection of wildlife is more important than the money they are making. That's the conclusion of this item. And that's what I had to share today. Thank you so much for listening to me. As if you have some concerns, you could raise it and together we can handle. Hello?
Hello?
Yes, please.
Yes, thank you so much, Teacher Samuel. Let us take on 2 questions, one from Kikaya College. Kikaya College, ask, and Palisa High School. Palisa? Okay, it seems also Palisa. Julius? Julius? Unmute. Ask.
Thank you, sir. I've not understood on how to draw the Cartesian plane.
Okay. You're talking about the graphing system here?
I think. Maybe you can just give a brief.
All right. Basically, if you want to graph, look at your constraints you have created. Like in this particular case, we had 4 constraints. With the first one as x plus y, let's say equal 50. 20, then the second as 20x plus 10y, let's say equal 800. Then the other 2 user ones. Now, if you want to plot, go one by one. The first one should be plotted using the line x plus y equal 15. That's what you should use if you want to plot the first one. You are going to use the line x plus y equal 50. We can. You use the line x plus y equal 50. And you take care of the line. This is going to be a full line. Why? Because it originated from the inequality less or equal. And when you go to our graph, don't forget that we plotted already. This is going to be the graph. X plus y equal 50 will be that graph. And then shading, I told you that this line divides the entire plane into 2 parts. The one above it and the one below it. So check from any of the 2 regions by picking on a point. For example, if you see that the origin is free, it's best to be used because it has very low handy values. The origin has 0, 0. So go and test 0, 0 using the inequality x plus y less than 50. On testing, you will substitute for x as 0 and y as 0, and you will discover that 0 is less than 50, which is true. If it is true, it means that the origin is in a wanted region. So you now shade the unwanted region. That's why this other part is shaded. You are going to do the same for each of these lines, and you will come up with this visible region. Thank you so much. I hope we are at par with the one who had the concern of how we come up with the feasible region. Are we at par? Hello? Hello?
Yes, Teacher Samuel. Palisa has a burning question. Palisa, go on.
There's a question there, fine.
Palisa?
Yes, thank you for the opportunity. I would like to know on the second equation, are we allowed to get a factor that goes through 20, 10, and 800?
20, 10, and
Okay, I think what is meaning, can it be okay to reduce that equation, that second inequality of 20, 50, and 500?
Oh, all right, it's just fine. It's just fine because you can end up with the dividing through by 10, factor 10. You'll have 2x, y, and 80. It's just okay. It's going to create the same. It will only affect your scale, but we shall end up with the same graph.
Okay. Okay. I think teacher Samuel, you can give your concluding remarks. Yes.
Yes, thank you so much, our dear coordinator. Our dear coordinator, my first thank you runs to you. Thank you for this great privilege you've given us as Ugandan teachers who are handling the new curriculum at first glance. We are very ready to handle this new curriculum, but we can handle it best if we are one, if we are in unison with the various stakeholders, more so the teachers. We can put our heads together and we shall excel with the handling this new curriculum in the best way possible. So this is a great privilege for us to work together as different subject teachers in Uganda. I pray that we continue with this program. It will take us to great heights. Then back to our students. I know the various schools are really busy with the day-to-day school programs, but you must pull up your socks if you are to attend to these programs. These programs are really enriching, academic enriching. So it's not good for you students to miss them. Ensure always you provide time for these programs. We are very lucky that some of our head teachers have really welcomed the idea and they are supporting us here and there. We are very sorry that the internet here gets off and on because there are so many using it, but we shall keep improving as we go along. Just praying that Mr. Kaziba, the Almighty God, blesses you as you continue giving us the privilege to work together. Thank you so much.
Okay, thank you so much. Before you go also, allow me to thank you so much, Teacher Samuel, for your time, for preparing this wonderful presentation. There is a lot we have learned from you. There is a lot. Indeed, we are really very grateful, and I'm very sure that everyone has really benefited a lot. It has been a very good session, and dear students, do not take linear programming lightly. It will be very rare for you to go for any paper, beat any mock paper, and at least you fail to find a number of that nature. So please, if you get time, go back and look at what Teacher Samuel has told us, summarize your work very well, and you'll be very good to score highly. We want to thank you so much, Teacher Samuel, and please, we want to thank you so much. Thank you for the great work. We are indeed very grateful. I want also to thank other teachers that have been on the call and all the school administrators that are really providing their best to the schools to see that they connect online. We are really very grateful. Next week is really packed with very many sessions. So next week, kindly prepare, and they are going to be very enriching sessions that we shall have. Next week, prepare that we shall have biology, have chemistry. We are going to have, those are the ones that have so far confirmed, but I just be sure that there is biology, there is chemistry, and also there is ICT, there is, so those ones have already confirmed that we shall have them next week. I'm yet to confirm, but also next Saturday, we shall meet to talk about projects. I understand you are supposed to do a project and some of you have not yet. Next week, we shall talk about project on Saturday of next week. We shall take you through all the phases, give you sample projects that you can work with, but that one will come next week, Saturday. But tomorrow, we shall have chemistry. Keep time. Tomorrow we may not have a lot of time, but we shall keep time that by 1, we are done with the chemistry. We have sent out some questions to you, and we hope that schools have already tried out some of those questions we shall discuss tomorrow during the chemistry session. You can prepare very well for those for the questions, but let me share them here. Maybe for some of those schools that have not yet received them, you can use this evening to go through those questions such that you are very ready for tomorrow. I know some schools may want to present tomorrow. Kindly prepare very well such that tomorrow we are really very ready. So I've sent the questions in the chat. I want to thank everyone. Thank you so much once again, Teacher Samuel, for that wonderful presentation. We are really very grateful. The answers have already been shared to you students in the chat. We shall share again everything for tomorrow. Okay, Kawala, those schools that are ready for tomorrow's chemistry seminar, kindly inbox me and then we shall have more discussion. I wish you a good evening, everyone. Bye-bye. Let's meet tomorrow for the chemistry seminar.